Great.
Recording in progress. All right. This is going to be a reasonably short one, I think. We've had our heads down working on a bunch of stuff, and there's some things to show, but then a lot of stuff that will all land in one go in the not too distant future, I hope. But some one sort of admin thing up front is I think we're gonna move to doing quarterly community calls. Um, because actually doing a good job of these community calls takes a bit of effort, and so we'd like to do them a bit less frequently and have more demos and more interesting stuff to show on each one. And then we'll probably do a written update once a month, like this month in Automerge, as a sort of blog post to keep people abreast of what's happening. Um, so I guess the next one will be in September, probably. We'll stick the dates in the calendar.
Yeah.
Um,
And of course, in between there, people can still find us in Discord.
yeah,
And if there's some reason that we have a big announcement or something, then we can do ad hoc calls as well. So,
yeah. But these kind of regular updates will move to a slightly slower cadence.
yeah.
Um, great. Okay, so then for this call, I'm going to talk a little bit about provenance. I'll get into what that is in a second. In Automerge, it's part of the supporting work for the Keyhive access control stuff that we're doing. And then Brooke has a bunch of things to present around the ongoing work on the new sync protocol. Um, and then we'll have open questions afterwards. And then we'll all go and have dinner or breakfast or lunch or whatever. Anyway, um, so I'm going to talk about provenance, and I'm just going to show some code. So in the Keyhive access control system, one of the things that we need to be able to do is, where's it gone? Okay, here we go. One of the things we need to be able to do is verify the authenticity, the authorship of any commit in a document, because we implement access control by filtering the document to only show edits from people who are authorized to see to modify the document. And that's important because it means that we can be local first. You can make changes offline, come back, and if you are revoked concurrently, then your edits are removed rather than having to uh, either always check some central place to see whether people are allowed uh, or not be able to talk about the history of edits that have been made. Um, so in order to do that, the model we've chosen is to sign each commit in the document. Um, and so this needs some, naively, we wouldn't have to do this with support from Automerge. You could imagine taking every commit in the document, appending a signature to it, like it's just a bunch of bytes once it's encoded, and then checking that signature. But the problem with that is that it will compress very badly. So we do a lot of work in Automerge to avoid storing the hash of every commit, for example, because we have a commit per keystroke frequently, or sometimes on like drawing applications even more frequently than that. And so what we actually do is run length encode everything and store just the heads of the document, and then we can rederive the hashes internally. And if we were to store a signature for every commit, we would lose all of that compression benefit. Um, so what we want to do instead is store the signatures whenever the author in the commit log changes. So what I mean by that is if you have a long string of commits from the same author, you only need a signature on the commit at the beginning and the commit at the end, because each commit refers to its previous commit by hash. And so if you signed the hash at one end, you follow the hash link all the way back to the last time the author changed, then you know that the author is the same. Um, but that there's a concept I have been talking about there, which doesn't currently exist in Automerge, which is the author. So another thing that we've added is the first thing that we've added is every commit now has an author field on it. So when you create an Automerge document, um, do I do this? Do I do this in here? Hmm, let's find it in the tests. Maybe I don't do it in this particular one because the signatures are a bit different. Basically, when you create an Automerge document, you can specify the author, and the author is just an arbitrary byte sequence. Automerge doesn't care what it is. We for Keyhive are using an ed25519 key, but you can use whatever you want. And that signature, that author will be stored on each commit, but it'll be tabled when we do a compression, so it doesn't get repeated for every single commit when you're sending many commits at once. Um, and then so that's great, but that means that the hash graph covers the author, and then we're additionally adding this idea of a signature, but the signature sits um, outside of the hash graph, so it's not hashed over when we create a commit, because that's what allows us to discard the interior signatures on a long chain of commits. Um, okay, so then the next question is um, how is signing managed? So the signature is also just a arbitrary byte string. Automerge doesn't impose any particular signing scheme. You don't even have to use a cryptographic signature. You could use just, I don't know, a central server that checks whether this signature is in the allowed signature list if you wanted. Um, and the API for this is, let me show you. So here is an example. So this is an example of creating this is just normal Automerge. There's nothing new here. But this is the new thing. So here we're creating an Automerge document that has signing enabled. That's what this signing true does. And then we apply the change that we just created. So here we created a change that said set doc.key to value. And then we encoded it. And here we applied it. And here we're seeing that this change has not been materialized in the document yet because we've enabled signing and we haven't done anything to verify the signature on this change. And the API for signature verification looks a bit like this. So there's this thing called signature state. You can at any point call reconcile signatures, passing this state to the document. So here's the remote document that we want to reconcile the signatures on, pass in the signature state thing, and we get back this report that says we need to verify this one signature. And then whenever you like, you can iterate over the pending verification requests from the signature state. And then you can mark it as complete with either a true or false, saying whether or not it verified, and then reconcile this back with the Automerge document. And now we can see, because we verified that, we accepted that signature, that the value is materialized. This works transitively. So if you receive a bunch of changes that don't have signatures, but they all have the same author, and then you receive a change that has the author and does have a signature that verifies, then all of the previously unmaterialized changes now materialize into the document because we were able to prove that the authorship that the authors of all of those commits is verified. That's and so signing works the same way. I'm trying to see if I have a test in this one for the signing API. Right, yeah. So here, signatures are the same. Roughly speaking, when you call this reconcile signatures thing, Automerge will tell you, oh, here's a commit I need to sign. I need you to sign. And then you go off and do something. Maybe you call into web crypto or whatever, and then you come back and you say, I've completed the signing on this thing. Here's the signature. And then you reconcile that back into the document, and Automerge will attach the signature to the commit that it was requesting signing for. And there's a couple of important things there is commits which Automerge is waiting for you to sign will not be advertised to anyone else. They won't be saved to the document or synchronized to anyone else over this via the sync protocol until you've completed signing, which means you don't really have to think about situations you don't want to get into where you publish a commit and then fall over before you finish signing it, and now someone else has a commit which they can never verify. Now, if you branch, basically that creates a situation where you might get a document that's stuck if you're trying to verify it. So we don't publish anything until we've verified the signatures on it. Great. Now, there is also an API for checking whether we have it on this branch. Oops. It might not be on this branch. Let me see if I can grab it. All right, I have made a mess out of this repo, so is that a real thing? No. Okay. There is also an API on some branch somewhere else that I have lost, where you can specify which heads each author is allowed to be at. So you can say this author, after these heads, they're revoked, which is how we then implement the full access control stack. That allows us to say we've verified the authors of all of these commits, and then these authors are not allowed to edit after this point. And that gives us a document that is access controlled according to the Keyhive access control model. I'll try and find that later and show it. But yeah, that's the model. Any questions?
There's a couple questions in the chat.
Oh yeah, I
First
can't.
one, did you already have an append only log beside the graph, or is that new?
An append only log beside the graph. What do you mean? What does that mean?
I'm guessing it's where you're storing signatures.
Oh, I see. So the signatures are an additional table in so this is a breaking change to the file format, which is we're going to have to make a few breaking changes for this stuff. So we'll do it all in one go. But the document encoding where we bundle a whole bunch of ops and commits together has now got an extra table for the signatures. And the commit encoding has a trailer for the signature as well. And the reason it's a breaking change is because it has to be outside of the hash envelope. And we don't have any concept of that currently. So yeah, so I guess no, we didn't originally have an append only log. This is a new thing.
And you mentioned it was a table, so maybe it's not actually an append only log.
No, yeah, it's just a table it's per the table is just to keep it because we don't want to stick them in the columnar. There's not really much advantage to putting a bunch of signatures in the columnar encoding. So
That makes sense.
And then Adam,
In
you also had
terms,
a second question. Oh, sorry, please continue.
yeah, sorry. Just in terms of like the ergonomics, it would be cool if you could pass a callback as like a third argument into change to handle the doing the signing.
The difficult with that is, well, I suppose we could do that. I like the explicit signature reconciliation stuff because it makes it much easier to handle things like debouncing. And I feel like the callback approach, the callback API probably belongs at a higher level. Like in Automerge repo, I think we probably would implement something more like that. But yeah, we could actually have. There's no reason you couldn't actually have both APIs in Automerge core, I think. So it's a good point.
I think that makes sense putting it higher level though, because like the debouncing does make a lot of sense. You're kind of like forcing that method of writing the code to make it easier to add debouncing when you get performance issues. Might be
Yeah, that's right. Because backing up, because we make changes very, very quickly. So I think I want people to be thinking quite hard about when they do the signing requests. Like because it's typically quite expensive to hand that stuff all off. And if you're doing you, you also don't want to get confused about when you complete the requests, so they race each other, and it's a bit easier if you're doing it explicitly. But yeah. Next question. Wait a minute. Maybe I can find the chat myself. Hang on. I'm trying to find
Those are the questions in the chat. I just thought it would give people a second of uncomfortable silence to
Oh, I see.
unmute.
Right. You're
Yeah.
just trolling us.
Indeed. Call hosting trolling. Yeah, exactly.
Cool.
All right.
All right.
Yeah.
Do you want me to move this drawing to point at anything else?
Yeah, just like move it just slightly off to the side because there's just those two images that we'll want it frame. I'm not going to show any code. So
okay,
this is me just talking at people, giving some relatively quick updates. So at Ink and Switch, we're pushing to release a bunch of separate local first conf I'm not going to talk too much about that because I think some people want parts of this to be a surprise. But that means, as the person writing the new sync system, we need to figure out how to scale things. And obviously, when you're writing the new sync system, anytime something's slow, they go, it must be the sync system. And so I took last week and pretty comprehensively benchmarked every part of the system and found stuff kind of all over the place, but found a few things that are in Automerge repo main that also might be helpful for folks that should be landing soon. So we found a couple n-squared terms in things like small things like key caches and whatnot, but that were as you're getting up into the thousands of documents. So some of the stuff that we're working on is like on first page load between 300 and 1200 documents just out of the gate. And at the upper end of that volume, if you have an n-squared term, then suddenly things start to get really slow. Or if you're running it on, instead of in the browser as a CLI tool, you see your CPU go to pin to 100% for a little bit of time and then come back down. So yeah, even though these are kind of like small edges of the system, they ended up not scaling well. And so we've identified a bunch of those and have patches for them, basically. So that's this first image on the side here. So it's not anything particularly technical. It's more just like identifying where those edge cases were. And so that should, in theory, once that stuff lands in the next couple of days here, speed things up for anybody else doing things at higher scales as well. Should be great. Subduction updates. So this is the sync system itself. I've had a couple people asking questions like, when's the beta coming? It's currently in alpha. When can I use this more for real? Stuff like this. And we're getting some pretty decent usage on it internally already. So that's the second image here. We've only really been using it sort of more seriously for maybe 2 months. And, even then it's not flat. It's kind of like increasing over time as people get more comfortable switching sync systems. But we are beginning, or I guess maybe early last week, we crossed 100,000 documents, set of entries in the terms of this system. And as of this morning, we're at 180,000. So we're almost doubling that now, which is great. It means that we're getting actual use on this. The downside is the way the system works under the hood is it takes an Automerge document, chops it up into things that, slices that are more recent. Data is very granular, and then the older it gets, the bigger and more compressed the chunks are. So some back of the envelope math, it's about 300, let's say, fragments of this kind per document, which means we have each of these has about 300 items on disk. So on the server, we're starting to look at inode exhaustion in the not too distant future when we start getting into the millions. So we are rewriting, or like we'll still leave the file system backend there, but we're moving to ReDB, which is a embedded database. Think SQLite, but fancier, basically, which is a rate optimized database. And that gets us a bunch of advantages. One, it will, for anybody who's already using the alpha, it will reduce the amount of storage on disk by about 3/4 because it handles the block layout better and has between 1 and 2 orders of magnitude faster fetches and is a single inode. So this solves a lot of our scalability issues. It's not the only option. Somebody in the Automerge Discord, I didn't quite catch who, asked about why not some of these other databases, and then I guess deleted their comments because I only see it in my notifications preview. And we did do an analysis and look at a bunch of different options, but ReDB seems like a good one in sort of the REST ecosystem where all this work is happening. When beta, I'm starting to feel kind of beta-ish quite soon. We're not making big changes anymore inside. This thing really has to work for local first conf. I'm spending most of my time these days on performance, not on semantics. So and nobody hold me to this, but I'm hoping beta release sort of like August, September sort of timeframe. And then things start to get more stable over time. So getting ready for more serious use with fewer breaking changes, with a more stable storage format, all of these things. And my final point here, Pushwork. So Pushwork is like a publishing tool. So you think of it almost like your Git command line tool. It's how you push and pull and clone Automerge repos. It has a particular, and specifically for file systems. So it has a particular format that it stores files in. These are compatible, with most file systems that, on Windows and Mac and Linux. And it's what we've been using internally to push and pull files. And a lot of this performance work we've been doing in Pushwork to speed things up there, because it's a much simpler, doing things in Node is a much simpler environment than in the browser. We used to have a tool called Darn, which was written purely in Rust, and we could do all kinds of fun Rust shared memory, multi-threading tricks to make it fast. And we've now moved most of those tricks. We've had to hack it a little bit, but we've moved most of those tricks over now into Pushwork as well, and even some of the UI from Darn too. So I know that there were a few people that were sad when Darn went away. They got archived a couple months ago now. But this is to say there's now a node-based tool that has similar performance and a similar sort of user experience. And so you can find that on GitHub at github.com. You can switch /pushwork to sync your files around. And yeah, those are the updates from my side, kind of rapid fire.
Nice.
Yeah, okay. Yes, yeah, it's nice when the speed up is fast. Going to ask about SQLite. What specifically about SQLite? Just like why not SQLite?
Oh, when you mentioned the database choice and you said it was basically SQLite but better, and I was like, oh, okay, well, that was the first thing I was going to ask was SQLite. So
yeah, so I both looked at benchmarks, but something I'm getting a lot of value out of LLMs with lately is having them write a bunch of benches and then doing a shootout, basically, using real production data. And ReDB and Fial were basically tied. SQLite was actually on the slower end of the ones that we were looking at, even though it's very, very, very battle tested. I think part of the reason is we were able to compile in very easily ReDB, and it has all of the, it just hooks into everything directly. That's part of it. And then ReDB is essentially a read-write lock system. And so for something that's read optimized and explicitly multi-threaded, it's just doing really, really well. And there's a reason that these things exist, to compete with SQLite. Yeah.
I mean, it's also not too surprising that we would be we're not really using the storage model we have is really simple. So we're not using any of the features that SQLite would offer, like being able to write SQL. We're pretty much just doing key value lookups with some range queries.
Yeah. Are those speed up improvements for Automerge specific or in general or specific to the new sync work? So bit of both. The ones that I was talking about here in this chart, that'll be Automerge repo. So anybody using the main JS wrapper for it. If you're using Automerge directly as Rust or WASM, you won't see that specific speed up. That was key caching relative to a database, the existing caching there. And there's also some updates for the node file system storage adapter, but instead of putting those on main, I'm keeping those on the Subduction branch for now, because we could break parts of that out for main, but there's a few places where I wanted to do some subduction specific optimization. So I was just like, I'll just stick this all together there. But there's another one of these n squareds so that one's on main. Anybody using Automerge repo gets that automatically. The other one is subduction specific for now.
There are, sorry, Karen.
Oh, no, please.
I was going to say there are some Automerge speedups coming down the pipe, mostly related to things like scanning very large maps or applying large patches. So some of these things are actually used a bit more outside of JS in the Rust ecosystem, where you maybe keep larger objects in the document. This is from some work that Ryan Henry's been doing on refactoring the columnar storage engine to be a bit more consistent and easy to work with, and that's yielded some modest performance improvements generally, but some small cases of like 75, 80 times performance improvements on like pathological use cases.
Yeah. And there's also now a branch in Automerge. I think it's version 3.3.0-fragments.1. So for this sync system, we need to do that chunking up that I mentioned before, which we call fragments. And we were doing that previously using the Node APIs and kind of using hidden APIs that we really shouldn't have been using. And it was really slow going over the WASM boundary continuously and all this stuff. And WASM, Orion has shipped a version directly into Automerge. So it hasn't landed on main yet, but hopefully soon. That speeds this up like 2000x on some documents and things like that. Like the numbers are just wild, the improvement, which is really helpful because now we can take all of that code out of JS land and have it work for everybody in Rust directly without having to cross that boundary all the time. Yeah. Adam was asking why Node instead of something like Rust or Go. I assume this is for the like I Git like tool for pushing and pulling.
For Pushwork, yeah.
Yeah. So we had a pure Rust version of this before called Darn, and it worked great. And maybe half the team was using that, and half the team was using this other tool, Pushwork. And we were basically told, well, we need to pick which one we're going to do. So, Brooke, do you want to maintain this in addition to everything else you're doing, or do you want to have the JS people maintain this tool? I was like, you know what? I've got enough to do. They can maintain this. So that's the main reason why. And then yeah, I was just in there to do some performance optimization on because obviously sync is a big part of that. I was just in there doing some performance work. My preference is for pure Rust, but you know, it works.
I think one thing there is the actual the way that we're representing files and folders is changing quite a lot. Because this is something that we use for like some internal projects which use this particular like correspondence with the file system. I think that once we're more confident of that layout, and Pushwork becomes a more broadly supported thing, I would personally want to have a Rust port of that for use in my own applications. It's just right now it would be a very frustrating thing to maintain because the upstream Pushwork is a moving target.
Yeah, I think rapid prototyping and experimentation is a good reason to use Node.
Yeah.
Yeah. And then is Subduction a new sync engine for Automerge core? Yeah, this is a great question. Sorry, I should have filled in some context off the top. So especially with things like end-to-end encryption coming, but also just in general, we've known for a long time that we need to do more efficient sync. So Subduction is a sync system for any hash graph. So it doesn't, because it has to work on end-to-end encrypted things like beehive protected Automerge documents, as well as unencrypted ones. It can't look at the data directly, which also has the benefit of we now have a design constraint that we can't materialize documents on the server. We have to just shuffle them around efficiently. And So this is replacing the sync system in Automerge repo. You can use it directly, in Rust, or port it around from there. And you can also, so you can do both encrypted and unencrypted, but even potentially multiple CRDTs if you need to, or Git, is a thing that we've been tossing around as an idea of things that we could also put inside of Subduction to sync around. So you could do, say, end-to-end encrypted Git, for example, without having to change the server. And so the part of the idea for local for software is that you should have interchangeable, easy to host components. And Subduction runs as a standalone binary, on a server. We have basically a staging server stood up. That's where these numbers are coming from. And then also gets wrapped in WASM, so we can sync it in places like Automerge repo. So if you want to play with it in JS, in Automerge repo, there's a Subduction JS branch that's also published to NPM under the Subduction tag. And Subduction, just the Rust repo I've posted in the chat. Normally, we publish it to crates, but because we depend on this experimental branch of Automerge currently with the fragments, until that gets published to crates, we can't push it because it needs all the dependencies on crates. So it's on GitHub for now. The latest version. Soon, yeah.
I will say as a little teaser that the potentially multiple CRDTs over it is not that potentially. It's there might be some experiments there.
Question, does that mean interfaces are going to have breaking changes for network and storage adapters? No, those all stay as normal. So Subduction has its own interface shape for everything. We use a hexagonal architecture. And then inside Automerge repo, we have a bridge that wires between the two interfaces. So you use a normal, this range query storage adapter, and that has a translation layer basically into Subduction. There might be some stuff. I was thinking probably the next couple days as I'm doing this performance work. Currently, we're getting bottlenecked in a couple places when we're doing these, thousands of documents at a time. One is if we're materializing documents on the thread that's doing sync, in Node being single threaded, we can't even reply to pongs or to pings with a pong while we're materializing that document. So if that takes 500 milliseconds, 2000 milliseconds, we're just stuck during that time. And the other side is in storage. We're storing so much stuff, and that's just piling up, waiting, asyncs. And IndexedDB in this range query style locks the entire database. So IndexedDB will lock per what they call object, but basically per table at a time. They don't go more granular. And so something I'm going to experiment with is maybe sharding or something like this to improve the throughput on the database side. And then for getting stuff off the main thread, what we've done in Pushwork is shard out a worker pool. And that's also improved. That's some of the stuff we were borrowing from the Rust implementation, except unlike in Rust, where you have a work stealing, Tokyo, all of this stuff, we basically had to fake our own version of it in JS. But yeah, all of the adapters will stay the same. Okay. And there's a lower level interface. If you want to performance tune, you can drop down a layer as well, but you don't have to.
So is this something that would only run on the server then?
No, it runs both.
Runs in the browser.
Yeah.
Okay.
Yeah, so on the server,
it solves
we
like
run
a definite problem. So.
Oh, what's the problem?
Well, I mean, that just definitely solves a problem because I was running into problems with Automerge repo and like how do you actually sync and merge documents on the server side when everything's encrypted. So seems like you're solving that.
Yeah, exactly. So we're kind of attacking it from two sides right now. There's this sync system that's end-to-end encrypted, capable and efficient for that use case. There is some overhead in size because we need to keep metadata on the outside of the encryption envelope to say, hey, here's here's what document this is, stuff like this. And so I'm shipping that half, and then John Mumm is shipping and has an experimental build as well of Keyhive. So all of the access control layer, encryption, all of that. That also runs over Subduction. Subduction's extensible, so you can plug in arbitrary handlers into it, so it knows how to do sync on these documents. But if you also need to sync, say, the authority graph in the case of Keyhive, he has a plugin for that. And then Automerge repo on the branch he's using knows how to sync, decrypt, ingest the Automerge documents, store it, all of that stuff automatically. So all that stuff should be landing, and I put this in giant scare quotes, soon.
I guess the other thing is with that, all that extra metadata, have you thought about potential security leaks?
Yeah, this is a great question. So we have thought about it. The information that you can pull out of it today is author IDs, and that goes down to the specific signer. So it has nothing to do with who, and more like, each individual person will have many devices, and maybe each device or each browser will have a key. And those are unique to that place. And so the metadata is, here's which Automerge document this corresponds to, here was the author, here's a signature. And the parent commits, basically the bits of the hash graph, to other encrypted chunks. The older those chunks are, the bigger they are, and the more compressed they are. So you don't see every individual commit inside for the graph. You just see this chunk has these parents, and presumably things coming into them as well. So you get a very sort of sketchy view of the graph, and it's not even necessarily who wrote that chunk or that fragment, it's who did the compression on it. That does leak some metadata, and we're not happy about that, but we want to get a first version out, and then we can change it over time. The next step, or like the proper way of doing this, would be to use a snark or some kind of zero knowledge proof. It has a bunch of advantages if we go that direction. The main downside of those is, other than complexity, they are quite slow for proving, like up to seconds. And most of the algorithms for those are going away very soon. So I'm not sure how closely people are following post-quantum stuff, but there's a article going around that essentially the community consensus right now is we have about 2 years until post-quantum, or until quantum computers can break keys, or specifically signatures. And that's most of the zero knowledge curves are gone at that point. So there's a little bit of like us hedging here, going, okay, new things are going to come. Let's ship a thing right now. And in the future, in a couple of years, when this becomes a problem, we can do an iteration on this. The other thing that we do is defense in depth. So there's both the metadata on the static, just like on the data itself, raw, but not just anyone can ask for that data. So if somebody were to break into the server and download all of the data, then yes, this leaks a bit of the graph metadata. But you can't just have some rando show up and say, hey, give me this document. You'll need to prove that you're allowed to request that doc in the first place. We assume that all cryptography is fallible and that everything can be broken. So the best thing to do is to keep the bytes out of people's hands as much as possible. That's an impossible task in the general case, but we can, do a best effort. Again, assuming nobody's in the server. When somebody's broken into your server, at least then it's still encrypted. Which is the long way of saying, yes, we have thought about this, but we're not shipping anything for it right now.
Yeah, it seems like you're thinking about it, but I guess technically governments could request data and get like a rough idea if the device is involved
Yeah.
right now.
Yeah, absolutely. There are things people can do to protect themselves against that. Like you can rotate your keys as frequently as you want, every keystroke if you wanted to. And I was talking to some activist types that were worried about, okay, if somebody, let's say they break the encryption and they can now see all of the data. And I want to have plausible deniability against it. This isn't something we've invented. This is something people do, is they'll have their, activist protest documents, work on it together, download a copy of it, and then publish the private key to the internet. And now anybody plausibly could have written that stuff.
It's an interesting idea.
Yeah.
So if you do rotate your keys, is that stored somewhere?
No, the keys are entirely. Is the fact that the keys were rotated stored somewhere? No, that's entirely up to the client. 100%.
Oh,
So you'd have
interesting.
to.
So it's just a different author, basically.
Yep, exactly. Yeah, we don't really keep, or yeah, at the base sort of ground truth level of KeyHive, there is no concept of a person. There are just keys and flows of authority through a graph. So the way that we create a person out of that is, you'll create your first key, and then it can delegate out to your other devices. Hey, you're also allowed to edit this document. But there's no distinction there between this is you, Adam, or this is your devices, or somebody else, or a collaborator, or a temporary throwaway key. There's no concept. It's totally homogeneous.
Yeah,
All
that
right.
makes sense then, because you can store that in that case.
Yeah, the keys themselves you can delete too. Like it's totally. In fact, that's what we do with documents. Documents also get their own keys. There's no distinction between a document and an individual, like a person. And so when it is created, it'll delegate to its owner and then delete its keys. So this is just like baked into the system that we do key deletion all the time.
All right. Think any more for any more, or should we sign off there?
Can I just double check my mental model on this? Because the
Mhm.
permissions changes are themselves encrypted things.
Mhm.
Do I understand correctly that this, like, once somebody is in the server, even if kicked out of permission from this document, they can keep pushing bytes into it because the server is unable to distinguish that they have been kicked out. You like need an
So
external mechanism if you really want to boot somebody separate from the document specific permissions.
yes, so this is so somebody's broken into the server and they're like dumping data into a document. This is the stuff that Alex was talking about off the top of the call, where we're signing and having provenance, right, on each update. KeyHive, which is our access control layer, has its own graph that knows for what point in time in the document's history was somebody allowed to write into it. And if they don't have permission at that point, even if there's more data, we ignore it. We just blank it out. It's tombstone it.
Got it. Okay.
Yep.
Thank you for
Point in
connecting those
time.
two.
Point in time there specifically means the heads of the commit graph of the Automerge document. So
yeah.
There's no way for them to backdate changes to before those heads that we would accept.
Yeah, like this is the tricky part of doing access control in this context is everything has to work kind of in scare quotes statically, right? So like we just have some data and we have some graph of authority. At what point in this graph, like which parts of this graph are valid? And if somebody writes after somebody who got kicked out, how do we retain those updates? The questions like this are the hard ones. Awesome.
Nice. All right. Well, thanks for hanging out, everyone. we'll be back again in September. But there's lots
Yeah.
that we'll be announcing before that, I think.
And come hang out in the Discord. Let us know what you're working on. Ask questions, etc. We're still around.
Nice.
All right.
Good one. Bye-bye.
Bye, folks.